Hi guys, welcome back to my channel. Let me provide a lasting solution to this simple palindrome polynomial equation. So we have a nice polynomial here, a quartic polynomial actually. We have 2s to the fourth plus s cubed minus 11s squared plus s plus 2 equal to 0. We have to find the value s plus 1 upon x for all real values of x. So solution, I will write this equation: 2s to the fourth plus s cubed minus 11s squared plus s plus 2 equal to 0. Now, if you look at the word, the English word madam, if you pronounce it from the left or the right end, it's still madam. This symmetry is actually what we have here. Hence the reason why it's called a palindrome polynomial. If you look at the coefficient of s to the fourth here, that's 2. Coefficient of s cubed, that's 1. Coefficient of s squared, that's -1. That's from the left end. If I also come from the right end, coefficient of, the constant term here is 2. Coefficient here is also 1. And I have -11. So from the left, 2, 1, -11. From the right, 2, 1, -11. Now, because of this symmetry, we shall divide this polynomial and redefine it so that we can have s plus 1 upon x before making a substitution. So I'll divide every term by s squared. So upon s squared here as well, s squared, s upon s squared, 2 upon s squared, 0 upon s squared will remain 0, so then for that. So s squared divide s to the fourth, that will give us 2s squared. S squared divide s cubed. The s squared here, we delete 2 s's there, we have just s left. S squared, we annihilate each other here, we have -11. Here, 1s we divide from the top and bottom. So we are going to be left with 1 upon x. Here we have 2 upon s squared, everything equal to 0. So I can then bring the square term and the inverse together, s and the inverse together. So we are now going to be having 2s squared plus 2 upon s squared plus s plus 1 upon s minus 11 equal to 0. So you see this. Very interesting and simple. Then I shall go to my algebra toolbox. We know that if we have a plus b whole squared, this can be expanded to give a squared plus 2ab plus b squared. Then if I attempt to isolate a square and b square, I think that is called sums of square. Okay, sum of squares. We are going to be having a squared plus b squared. That will be equal to a plus b whole squared minus 2ab. Now, with this well-known identity or algebraic formula, I can actually write an expression for 2s squared upon, 2s squared, sorry for the slip, 2s squared plus 2 upon s squared. So I can decide to factor out 2 first so that it can be more refined. We now have 2 into s squared plus 1 upon s squared. So if I use this formula, I can rewrite this expression. So I'm going to be having s squared plus 1 upon s squared. That's going to be s plus 1 upon s whole squared minus 2. Exactly what we have here. A squared plus b squared is a plus b whole squared minus 2ab. So s squared plus 1 upon s squared is s plus 1 upon s all squared. Okay, this should be a plus. Okay, minus, we are correct. If I had written this, would be a plus. So 2s squared plus 2 upon s squared, that can be 2s squared plus 2 upon s squared. Will now be, I will use 2 to multiply the right hand of this expression here. That becomes 2 into s plus 1 upon s whole squared. 2 multiply -2, that will give us -4. What a problem. Then the original equation here, this guy, in place of 2s squared plus 2 upon s squared, I shall write this expression. We then have 2 into s plus 1 upon s all squared minus 4 plus s plus 1 upon s minus 11 equal to 0. Please manage this space, okay? It's visible. I'll then say, let k equal to s plus 1 upon s. So here, I'll be having 2k squared. Here, I'll be having negative 4. S plus 1 upon x, which is k. I'll be having k. I'll be having negative 11. Everything equal to 0. This junction, we adjust my classes. We have done very well. Now, this is a quadratic equation. We can clean it up. Clean it up. Okay, that should be a collection of like terms. 2k squared is alone. We write 2k squared, k plus k, negative 4 added to negative 11. That will give us a negative 15 equal to 0. Then this is a quadratic equation that I guess is factorable. 2 multiply negative 15, that will be negative 30. 2 factors of 30 that can be added to give 1. That should be negative 5k and 6k. Yeah. If I add negative 5 to 6, I'll get 1. If I multiply negative 5 and 6, I'll get negative 30. So we shall infuse this in place of k. For the sake of our audience in high school, I will take this part off. It's just one lap to go. So I will write 2k squared minus 5k plus 6k minus 15 equal to 0. Factorized by grouping. Okay, totally 6k. Okay. So 2k and 5k. I think the highest common factor there is k. Factor out k. Then we have 2 divided 2k squared, that will be 2k. 2 divided negative 5k, that will be negative 5. So here we have k fully common. Factor out 3, which is the highest common factor. 3 divided into 6k, that's 2k. 3 divided into negative 15, that's negative 5. Everything equal to 0. So we have k plus 3. 2k minus 5 equal to 0. Then from the zero product property, it implies that k plus 3 equal to 0 or 2k minus 5 equal to 0. So if I subtract 3 from both sides in this first equation, I'm going to be having k equal to negative 3, or in this equation, or this second equation, linear equation here, if I add 5 to both sides, 2k will be equal to 5. So our two values for k are k equal to negative 3 or k equal to 5 upon 2. So if we were to solve for the value of s plus 1 upon s, that should have taken a longer time. Guys, we needed to find the value of x and add it to its inverse. But our substitution has refined the context of this problem. So you can see that I will recall that k is equal to s plus 1 upon s. And that's our target. So s plus 1 upon s is either going to be negative 3, which is the first value for k, or s plus 1 upon s equal to 5 upon 2, which is the second value for k. So guys, we've come to the end of another interesting tutorial. Please ensure you like and share this video. And don't forget to put your comment and subscribe. See you next time and stay blessed. This is your homeboy, Sir Chris.